Okay, 8.3 is area of composite figures. In this box, you have the formulas for finding area of all the different shapes you might need throughout this section. Again, these are things that we've already worked on, so unless you've come to talk to me, I think you understand this and are good to go to make it a little more tricky now. The way this section works is you might be given a composite figure, you will be given a composite figure that you have to break up into different shapes. So if you look at this first one, you have to see that if you draw a line there's a parallelogram and a rectangle. So then you can find the area of the parallelogram, area of the rectangle, and together have the area of the whole figure. Again, on this one, you notice there's a semicircle and a square. So you can find the area of each, and then you have the area of the whole thing. And then on this one, a trapezoid and a triangle together. So I'll tell you, the trapezoids are what people struggle the most on when identifying a composite figure, when identifying the shapes within it. So always remember what a trapezoid looks like, because that's what people struggle with the most. 1A, find the area of the composite figures. Which two shapes are combined to make the figure? After you find the area of each figure, what would you do? So the first thing we're going to do is draw a line here, because it was supposed to be on there. And we notice that this is a semicircle and a triangle. So to find the area of a semicircle, I take area equals pi times radius squared. Now it gave us the diameter of 6 meters, so that makes our radius 3. So we say A equals pi times 3 squared. And we do that, and so we get 9 times 3.14, and we get 28 and 26 hundredths. But it's a semicircle, so we have to divide that by 2, and we get 14 and 13 hundredths for the area of the semicircle. So we're dividing this by 2 because it's a semicircle. So that's the area of the semicircle. Area of the triangle is A equals base times height, divide by 2. You have area equals 11 times 6, divide by 2. Area equals 66, divide by 2. So the area of the triangle is A equals 33 meters squared. And this one was meters squared as well. I didn't do that. So then I add them together, and I get the area of this figure, and to change the color so it stands out, is 47 and 13 hundredths meters squared. Circle it, and that's my answer. Okay, 1B, find the area of the composite figure. So first thing I'm going to do is draw a line right here to split this up so that I have a trapezoid, and it looks like I would have a square actually. So this line right here is 25. I'm going to highlight actually. That'll make it easier. This line is 25 and this line is 20. So if I want to know what this is, oh, okay, that's too big. If I want to know what this line is right here, I take 25 minus 20. So that makes me know that this right here is 5 inches. I know that the whole height, or this base that I did on the black line, is 20 inches because it's the same length as over here. So my trapezoid area equals the height, which is 5, times base 1 plus base 2, all divided by 2. And then my square is area equals 20 times 20. Area of the trapezoid, I solved that. I didn't leave myself a ton of room to do so. I have 5 times 33 divided by 2. since I don't have a ton of room, I'm just going to plug it straight into my calculator. And that gives me 82.5 inches squared. And area of the square is 400 inches squared. So add these together and we get 482.5 inches squared. Circle it, and that's my answer. 2A, find the area of the shaded region. So the first thing I'm going to do is find the area of the whole rectangle, and then I'm going to subtract out the triangles of each corner, and then that will leave me with the area of the shaded region. Every time you see a problem like this, your game plan for solving it might be different than mine, and that's okay. As long as you're getting the right answer, you might see that this could be broken down into a rectangle and two different trapezoids. And you may do it differently, and that's okay. So just because I'm doing it one way doesn't mean that's the way you have to do it. That just, to me, seems like the easiest way. So if I have my rectangle, my outer rectangle, the area is base times height. So the area of that outer rectangle is 60 inches squared. And then I have this triangle right here. And the base of the triangle is 1 and the height of the triangle is 1. So I'm going to do triangle. And area equals the base times the height, divide by 2. So the area of this triangle is 1/2 of an inch squared, but there are 4 of them, so I'm going to multiply by 4. So the area of all the triangles is 2 inches squared. And I'm going to take 60 minus 2, and I get 58 inches squared for the area of the shaded region. Circle it, and that's my answer. 2C, a diagram for a park is shown. The shaded area represents the picnic sections. Find the area of the picnic sections. So the first thing I'm going to do is start with the rectangle that is blue. So that's a picnic section. So the rectangle is 60 by 25. So I'm going to take A equals 60 times 25. And when I do that, I'm going to get 1,500. So the area of the shaded part is 1,500 yards squared. Then I'm going to do the area of the triangle. Okay, I know that the height of my triangle is 50, and I get that from right here. That's the same height. So A equals, I know my height is 50, and my base, I'm going to do it in a different color. Since this whole thing is 150, and up here it's 120, I know that this that I'm left with is 30, because 150 minus 120 is 30 yards squared. So I take 30 times 50, divide by 2. And when I do that, I get 750 yards squared. So the area of the triangle is 750 yards squared. And then I add them together, and the area of the whole shaded region is 2,250 yards squared. Circle it, and that's my answer. And the video is done. It just won't pause.